Okay, so let's get started. How is everybody doing so far in SPCC? Good? Okay, so let's get started. Welcome to this session of Artificial Intelligence and Machine Learning introduction. So this is for everyone. What I'm trying to achieve in this 1-hour session, quickly start with in such a way that everybody and anybody can be involved, and we're gradually going to start with some basic concepts of machine learning, but then graduate to overall comparison of how AI, machine learning, and deep learning compare together each other. That's the theme which I want to keep together. We'll start with very basics and keep on graduating. I will try to make it interactive to see if we can respond to questions, apply some actual use cases and patterns together with this. So, as I mentioned, it's trying, my goal here, my name is Raju, I'll give a little more introduction of myself in a little bit. His goal is to simplify and further simplify so that everybody gets it, not only gets it, but able to take it and preserve whatever learnings which you have for a much longer period of time. That's my goal. Let's see how far we go with that, okay? So, what we're going to do is going to talk about the basics of machine learning, build into the deep learning comparison, AI, and then see what the industry has to offer in terms of ML and AI offerings. There's a lot of buzz and excitement about machine learning these days, and end up with some of the use cases and patterns which are happening in the industry. If time permits, we'll do a little bit of demo or at least some experimentations around it. I'm part of the company Big Data Trunk. What we primarily do is 3 things. We provide corporate and individual trainings to large universities, as well as corporate Fortune 500 companies like Salesforce, Amazon, and several of the other companies, Cisco's and so of the world, and Stanford University and several of those things which we provide training services, we provide consulting services, also in the data analytics space, whether it's on the cloud, whether on-premise, but it's all related to data and analytics. And of course, we help our clients and ourselves some of the interesting data products. It's an exciting time to be in the data world. Myself, Raju Shreewastava, I've been blessed to be in the industry for data side of the world for 21 years. It's always keeps on getting more and more exciting, and the fun keeps on increasing and the buzz keeps on increasing. Right now, I think it's the pinnacle of what excitement and buzz could have, and that's why AI and machine learning is heard everywhere, anywhere, which you see. I'm the founder of the Big Data Trunk. 4.5 years we started this company, and it's been going phenomenally growing, and we are getting a lot of excitement. The team keeps growing, and the work as well. I have a lot of passion for teaching and sharing, and we do that. Me, myself, our team. Anthony was presenting yesterday. Some of you may have joined his session yesterday around AI. And we have a lot of passion teaching, and we share in some of this conference. This is Dreamforce conference. This is Silicon Valley Coding Camp in the Evergreen a few years back. This is Santa Clara Convention Center. The topic probably is machine learning. So I have been fortunate to be able to share and discuss along with my team in several of these conferences and places. I've been an author for 2 books. My first book was for Pearson publication. This is how to take big data into enterprise level, how to do a high availability and disaster recovery and all of that for enterprises for big data, which resulted Microsoft to reach me for the second book, which is work in progress, how to take big data into their landscape of what they have cloud, which is Azure, Microsoft Azure Cloud, and they have an offering called HD Insight on top of it. All of that is available on Amazon, so if you wanted to check out, connect with me. I've met a lot of interesting and great people through these conversations and several other things. We have a meetup group around 3,500 people, so I'll share some of those details as well. I want to quickly get a pulse of the group. So if you can raise your hand in the sequence, I'll keep on asking questions. How many of you are on the software side of the world? Keep your hand raised if you are working on the data side of the world, software and data part of it, okay? Keep your hand raised if you can, if you're working in big data. Very few. How about AI? AI, ML. Okay, 2 hands. Okay, interesting. So very few people in the AI, but most of the folks are from the software background. So that gives me a background like where people are coming from. And the expectation on this session is like you know zero about AI, which is rare now these days. You know at least some of the things. But I think that's what expectation. Slowly I'm going to build upon the concepts as we proceed further. Thank you for sharing your background. I want to start with a question. So what do you think when this AI revolution or AI thing has been when did it get started? I know some of you know the answers already, the correct answer. I'll take a couple of guesses.
As soon as the last person just walked out of the room.
Sorry?
As soon as the person was standing and just walked out of the room.
And what about that? He's Peter, he's the organizer of the whole event. So what else? Anybody, any guesses? 50 years ago? 1950s. I think a lot of these people have understood this. It's not a new phenomena. And some may be surprised. Some may be thinking it's 5 years, 10 years back, which machine learning or AI has started. It's not the case. It's been there for a while. It actually started in 1950, correctly said by some of the folks in the room. And it started, one of the biggest buzz or excitement around this started when something called Turing test was done by Alan Turing. He's an English professor, and he devised a method where, think of it as almost like a chatbot, where a human is interacting with a chat kind of mechanism, and he does not know whether the other side is responding a chat machine or it's an actually human being. And this iteration or test keeps on going on a particular topic for series of a time, and if 50% of the time the human is not able to guess whether it is chat or not, he's confused or he's getting it right or wrong, 50% of that kind of a guess, then the computer or the AI part of it has been successful to really be successful and see what it is actually an artificial intelligence. So that's kind of one of the premises which started back in 1950. Alan Turing has done a lot of work around that. And I just want to give a quick history of how things have happened. This is not the first time which AI has got an excitement. Actually, this is the third wave of AI, what we call it as. It started back in 1950 with the Turing test. And then a lot of excitement and buzz happened in the mathematical, statistical side of the world. In 50s and the 60s, a lot of these algorithms which you may be hearing now and getting a lot of excitement and buzz around neural networks and nearest neighbors and algorithms, they were actually written back in 50s and 60s. That's nothing which has been written now. So if human beings have tamed actually the math and the statistic parts so well in advance, why don't you think like, why would you guess like it's not, we don't have machines and robots actually doing everything for us and the revolution has not happened? Why did this become not such a buzz in the 50s and 60s? Any guesses why it was not so successful or didn't solve the promise what it's actually attempted to do? Not horsepower, I heard data. And those two are the thing. They nail it, completely they nail it. So we did not have the right amount of data which to really give reasonable predictions, and that kind of data has been available now with the buzz and excitement and all the revolution of big data and Hadoop and MapReduce and Spark and all of that in the big data revolution, which has happened for 15, 16 years now, and that has allowed us to capability to really show how you can address a humongous amount of data and to be able to tame it. The second point was horsepower. The compute capabilities were not there. In fact, I would go to the extent of saying that somebody, if they wanted to create an Alexa kind of device in the 50s or 60s, technically the person would have been successful, technically. But here is the user experience. There is an Alexa device sitting on a table in 1960s, and a person asks that device, how is the weather going to be tomorrow? The machine spins for a month and gives the wrong answer. That's kind of the user experience which would happen, and user experience is the key. So technically possible, but user experience-wise, it would just flat fall on its face. So that was the challenge which I think people have summed it up very correctly, and that resulted in something called as the first AI winter. A lot of the funding, a lot of the excitement died down with this period of time. Of course, there were activities and work which was happening, but it did not have the momentum or the buzz which initially where it started from. So it stopped at that point of time. So this was the first winter. But work kept on happening. Stanford created something as Stanford cart. It's almost like a vehicle or a mechanism which really drives itself in a room or reaches a position without bumping into things. So that was the kind of thinking Stanford did. One of the big glorified or publicly popular event was in 1996, 97, actually, when IBM Deep Blue really beat Garry Kasparov in the chess competition. So that was a big aha moment, like, oh, a machine can really play chess in sophisticated game and be able to beat a human champion of champion. Actually, Garry Kasparov won the first component in 96, and then the machine learned better and came in next time and just beat Garry for the second time. So that's the kind of the buzz which is happening. Now this kept on happening. There was fundings, lack of fundings, just the winters kept on happening. In 2006, the word deep learning was coined. It is not something which is happening now. It has been coined in 2006. Now we are seeing a lot of excitement around deep learning. Anywhere, everywhere you go, you hear about deep learning. Jeffrey Hilton coined it. He defined the neural networks kind of mechanism and system to do it. He's now working in Google in some of those kind of revolutions. He's a fellow in Google working right now. So what has changed now? Along with the humongous amount of data, along with the compute capabilities, what has happened in my mind is a lot of commoditization or packaging in such a way has happened by companies like Amazon, Google, Microsoft, which have provided these offerings in ML AI in such a packaged way that it's been commoditized. With few clicks, people can start doing some kind of AI and ML, and I'll show some of that and talk about some of those things as well. So that commoditization, along with the humongous compute capability and ability to address large amount of data, has really brought us to this point where AI seems to be happening in full swing at this moment of time. We don't know if it will fulfill all our promises, but at least seems to be very exciting and a thing. What next? Further things happened is continues in the game. There is a more sophisticated board game, just has more sophistication in certain ways, but the amount of movements which you can have, the possibilities which you can have, Go has much more than that. So actually a machine took 20 years to beat the champion in that category after Gary Kasparov's loss in 1996. So there has been a lot of these things get publicized, which show in a way that there is an excitement, there is a buzz, and actually machines are getting better and better in certain kind of activities in something. What next? Where does it all go? One theme of popularity is called singularity. How many of you have heard about singularity? Okay, only few. So singularity is a concept which has been provided and predicted by futuristics people, and they have defined as there is going to be a point in time where machines will be able to have more intellect than a human being. And that's a tipping point. When one machine becomes smarter than a human being, it can go in a cycle which it creates a smarter machine and a smarter machine and a smarter machine, and it reaches to a point where this has been carved into a graph, timeline kind of a graph, and where we are looking at how quickly machines are becoming more and more intellect. And at this point of time where it surpasses the brain of a mice, then a human being, and at some point of time, it's all prediction, it's thought, and 2045 is what is predicted, roughly 2040, 50s, in that range point of a thing, where a single machine has the collective intellect of all the civilization. That's a real powerful and scary thing at the same time, right? So that's kind of the buzz and excitement which is happening, lot of activity happening in the space, and this is what singularity is predicting. Nobody knows, but definitely the growth in compute capabilities and what machines can do has dramatically been increasing, right? What has happened, as I said, there has been this buzz and excitement, and then there has been this winters and this fall. A lot of people have become skeptical whether this time is going to happen or not. Is it going to be another time again a wave and it just fades away by itself or not? I believe that it's already happening. We have the Roombas of the world cleaning our houses, the Nests of the thing, regulating things and temperatures, and a lot of excitement. We have got into speaking devices, assistants, Alexas, and the Google Homes and Siris and everything. They're working. They actually work with all the accent, all the different possibilities. They keep on doing more and more, especially homeworks, right, for the kids. My 8-year-old always gets all the spellings correct because of Alexa, thanks to Alexa. So that keeps on happening. These are simple things which have been happening. Now human beings are trying to move to what is called a general AI. Not specific point and solutions, but reach to a point where it could be much more sophisticated things like driverless cars. And technology exists. We already know in the Bay Area there is a lot of these kind of vehicles going in. It's more about the regulations, the safety precautions, where it can be produced in mass scale. So we are moving to that age or step. There is also, this is Sophia. She is the first citizen, a robot, a citizen, given by UAE the status of a citizen to that. So you can interact in human gestures and everything. So that the world is changing. It's scary, it's a strange world which we live in. Finally, we also know there is people like Elon Musk who are very popular. At the same time, they have raised their voice against AI and what the potential threat it brings to us, right? It's a doomsday. Stephen Hawking, Elon Musk have talked about it. But at the same time, Elon Musk has created this company, Neuralinks. How many of you have heard about Neuralinks? Anyone? Very few people. So he, in a certain way, when I reflected back on it, has created first human defense. So his thought processes embed some compute capabilities within human beings, almost like in a crude way, put a chip in your head. And your brain has much more sophistication to be able to compete with that machine who's going to be his threat or fear is is going to be against us in future down the line, and this is our only chance to stand against the defense. So that's what his thought process and what he's building around. So a lot of changes happening, lots of excitement happening in the AI world already. And I'm not sure, and or rather I could say, it will not possibly solve everything in the world, but it's already doing a lot and lot. So let's look at that this way. Now, that's a little background and things around what is happening and what not. Let's get into some of the concepts, how technologically this is happening, some concepts, fundamentals, and how slowly step by step we'll go distinguishing AI, machine learning, and deep learning. So to start with, I want to start with machine learning as a promise, what machine learning is, and then go one step by step with other things. Let's start with machine learning. Before I start, I'll just take one or two questions, responses on this one. What do you think is machine learning? People have different viewpoints and thoughts. There is a lot talked about, so I'm sure you have heard some things. It may be myths, confusions, but I want to just take a pulse. Like, what is machine learning? Anybody? Okay. Okay, so learning, if I generalize that, you talked about a Roomba example or some kind of vacuum kind of cleaner, that's perfectly the example where it learns from what its data points and improves and does better thing next time. Anybody else? Any other thought process? It's a quiet crowd.
Learning from data and predicting outcomes.
Okay, that's a very official and correct statement. People look at it from different angles. I'm going to approach it from a very, very different angle. Most of you said that you have done programming in some form or shape. Even if you have not done, you know how it works. So I want to compare and contrast programming to machine learning, how that gets differentiated. In terms of programming, what happens, there is input data. Let's take a simple set of data, just 1, 2, 3, 4. And in the programming world, a programmer has been asked very prescriptively, a rule-based specific question, can you actually do this program and make the square of single number? In our case, I've taken a very simple example where the programmer has been asked, just take a number and make a square of it. He has a computing device, of course, and whichever language he picks, and if nothing, no compilation, syntax errors, this is what should happen. The 1 will get converted to 1, the 2 would convert to 4, and so on and so forth, right? This has been happening for decades. That's what software industry has flourished in several forms, rule-based automations to do in a broad level. That's what's been happening. Now, how does it differentiate in the machine learning world? In the machine learning world, let's start with the same data set to do apples to apples comparison, input data, but we do not have a prescribed rule. Nobody's saying the programmer do this, exact model, exact rule. Instead, we have outputs for those scenarios. Can somebody decipher what is the pattern between this, or all of you attempt, what is the pattern between these inputs and output? Cube? It took seconds. It took seconds for us to really do that. What you did in your head is exactly what machine learning is. This is what you probably did. You took the first number and compared with the first output. 1 is 1. You can't decipher much out of that. 2 became 8. You got a hunch or hypothesis which says, oh, seems like a cube. You wanted to validate it further. You went for the next number. 3 became 27. Some of you became very confident and said cube. Some were a little cautious. They looked at the next number and became like another round of testing and everything. We were all good because it was just 4 numbers. And the formula was simple. If instead of 4, if it was 4 million or 4 billion, we human beings step back very quickly. And if it was a complicated formula, that's not something which we are great at. And that's where machines come into picture. They can iterate through this series and amount of data and millions of data and then come up with a model. And in this case, they would have come up with something called as y is equal to cube of x. They would have found the answer. But that's not something which human beings are great when it's humongous amount of data and when the formula or the model is not that simple and straightforward as well. With that data, as people pointed out, it can be used for future predictions. 5 becomes 125. So it's a paradigm shift if you think from that perspective. We had a rule-based prescribed engine where you were given a formula, a rule, and you coded that in your favorite language. In this case, that's not the case. Here you are getting the output which is going to be the model or the formula which is going to be spit out. Is it making sense? I'm going to start with very, very basic things and slowly we'll keep on building all the concepts which we need for machine learning and have a sensible talk, and we'll try to apply that into a use case. I'll need your help to do that, so pay attention. So with that, let's move forward. You may have heard about the term supervised, unsupervised. I'm sure how many of you know that very well already? Most of you, right? I'm going to put a different twist to it, a different example for it. Hopefully that not only you know it, you remember it and can understand it in a much more And some of people take for granted that they know it. They may not actually know the real basic foundation. So let's take a simple example. I'm going to take a basket of fruits. We have a basket of fruits with different kinds of fruit. What I want to do is separate all these fruits. All the apples in one place, all the bananas in another place, and so on and so forth. If you even ask a kid to do this, the kindergarten kid to do this, they will take few seconds, a minute or so, and they will be able to do this exercise very easily. How are they able to do it? They're not sure how they're exactly able to do it, but they are able to do this answer. Somehow the answer is sitting in their head. They have learned in their few years of life through charts, through books, through marketplace, through YouTube videos, their teachers, however they have learned, and they fit that thing, that image in their head along with the answer. When you have that answer available with you, that is supervised learning. That is supervised learning. In fact, if I ask somebody to code, even us to how do you really differentiate between these fruits, we cannot write a program. You might write millions of lines of code and be wrong. There is no formula or program to find fruits. They're not taking litmus paper and checking the colors and kind of thing, the size and the shape. There is nothing as such. Actually, such problems, forget the speed and accuracy, such problems are not designed well enough to be really done by traditional programming. And that's where machine learning and AI comes much more forward and does thinking like a human brain does. So this is supervised learning whenever you have labeled data. What I mean by labeled data, you have the data in row, it's of this particular fruit, this is yellow in color, this particular size, weight, and it is called as banana. When you have that banana label defined it, your answer is defined, that's what is supervised learning. To understand completely, we have to talk the other side. So let's talk about the other side. In case of unsupervised learning, we are going to have the same problem. Let's start with that. We are not going to call the kindergarten kids. I'm going to call aliens from another planet this time, right? As if I have the power to bring them. I'm making two assumptions about the aliens, that they are not colorblind. I don't know, I've never met an alien, so I'm going to make that assumption. The second assumption I'm going to make is the aliens are not knowing about fruits. Their planet does not have fruits. Lucky us, we have fruits, right? So with those two assumptions in mind, I'm going to ask them to do the same exercise. They end up doing something like this. That's a little different than what the kids did and what we expected, but they did something like this because they did not have the answers. They did not have that label data. They had something like this particular fruit, this particular color, this particular weight, size, and that's it. It did not have a field which said it's an apple, it's a banana. When you do not have the label, it is called as unsupervised learning. Whenever you have a thing. We'll take a few other examples, and your data clearly says whether it is supervised learning or unsupervised learning off the bat. As soon as you see the data set, you should be able to distinguish and say whether it's supervised or unsupervised. Making sense? So I'm starting with very, very basic things, very simple examples, and that's my goal, to keep it as simple as possible so that it does not only you understand it, but retain and understand it for a much longer period of time, right? Most of the questions I'll take in the end, but if you have like burning questions, please ask that in between. We'll see how we can fit in terms of time. Supervised, unsupervised. Now I'm going to quickly take another example for supervised. Let's say we have different kinds of coins, and so that I've just bring that example clearly. And we want to identify, based on some characteristic, whether this particular coin is what kind of coin. It's a Canadian coin, it's a US coin, or whatever. You have these fields, let's say, the diameter, the thickness, and all these values have been provided. And then this is the label what I was talking about. You have the answer. If your data field has an answer with this, it is supervised learning. I want everybody to be as simple as you think. You see the data set, you have the question in your mind, you know this is supervised learning you're dealing with. So that's what is happening. We have these different features or attributes which we call as features, diameters and things, and the currency is the output, and supervised learning is defined. In case of unsupervised learning, what would happen, we have a bunch of data. Unfortunately, that's not very clear to see, but let's say it's data about particular game and pitcher and hitter for the baseball, and it does not specifically say that this person is a hitter or a pitcher in the data set. It just has different attributes about the person, and it does not have that. When you're doing that, and it does not have that field, that's unsupervised. Just wanted to throw that one quick example from the data side which you see, and you understand that clearly. Everybody okay so far? We have a quiz or kind of an application to solve together, so that's why keep in mind. I'm throwing some hints in between. Let's see how many of you have it and keep it along with you. Let's keep moving. In interest of time, I talked about comparing traditional programming with machine learning. We did supervised learning, unsupervised learning. Now I want to go one level next. There are broadly 3 techniques in machine learning. There are most of the things which you're doing in machine learning can be solved in these 3 techniques. They're called as classification, clustering, and regression. If you notice what I've done, I have made these initials as red and bold, creating an acronym, and it's called CCR, so that you remember this for a longer period of time. I used to teach kids, so I use all these tactics to really remember things. And CCR is a simple technique which I could define whenever you think about it. It's classification, clustering, and regression. So I will go one by one quickly, one example of each so that you understand it, and then we'll try to apply this. A quick hint which I want to throw in is clustering is unsupervised learning. Just to remind, clustering is unsupervised. Of course, that means other 2 are supervised learning. What is classification? Classification is a supervised learning technique where you take your data point and then you want to put in one of those categories, one of the predefined categories. For example, in this case, we are taking different vehicles and we are looking at some questions. This is a decision tree, one of the methods, and based on this question, yes, it's high mileage. If it is not, you ask some other questions, it's low mileage, high mileage. So what we are doing, we are taking our data set and going through a set of questions. These are questions which the computer has defined, the machine has defined, not us. Automatically, the machine found this kind of questions. And then it's kind of defining those into some kind of category or a class, that's why we are classifying that. This class is predefined. It's a predefined class. It doesn't have to be binary. In this case, it is high mileage, low mileage. It could be low mileage, high mileage, medium mileage, very low mileage, and so on and so forth. It can be any of those things, right? So this is what classification is trying to do. Take a single data point from your collection of data points, go through an iteration, and predict its category, which category it belongs. For example, there is spam and not a spam. Now going to clustering. In an example of clustering, I am going to again call the aliens back on the planet Earth. They come on the planet Earth. They do not have plants and animals on their planet, and they just observe things around. By observing, they find 2 patterns. One, there are things which are non-green on the planet Earth, and they run around in different directions. If it's a lion, it's coming to eat you. If it's a deer, probably it's running away, right? But it's running in different directions. And there are things which are green, and they do not run away. So that's what is plants. Just by mere observations, they found these things into 2 categories, the animals and plants. They did not have this label, they did not have the answer, but just by mere observations or some attributes, they have been able to identify these 2 categories. So that's, at this point of time, some people get confused between classification and clustering. Anybody, is it making sense? It's very clear. If you have questions, let's take it handled right now. The key difference is, somebody say, that was again also, we had high mileage, low mileage, and this one also animal plant. That part is the same. That part is correct. But the other key difference which I want to highlight is what you care about in case of clustering is the overall pattern. You're not dealing with one individual data point. You're not worrying about that. Let's consider this example, the blue and the red, as tweets. Tweets coming from Twitter, and this is the kind of whether it's favorable for Republicans or Democratic, the 2 parties right now. And based on that, these tweets are coming, and what you're getting is the kind of pointer whether which of them is bigger. So just without even going in particular details, just by having these clusters and these 2 groups, we are able to identify that the red seems to be more talked about at this moment of time, right? So just by that pattern, this is helpful, and still you'll be able to get some insights. Versus, in this case of classification, it is about one data point. This particular vehicle, whether it is high mileage or no mileage. So if you're predicting about a single data point, you're dealing with classification. If you do not have the labeled data, but also you're dealing with the patterns, that's what is clustering, which you're trying to do. And the other key difference is these predefined categories are predefined. These categories are predefined. You say that I want to be going into the high mileage, low mileage, medium mileage. In this case, we did not know. The data is going to come out with some kind of groups which it thinks as clusters. So that's few subtle differences. Just want to make sure everybody gets that, understands that. So let's move to the last one, regression. Regression is a supervised, and this one is wrong, by the way. This is unsupervised. I should fix it. I fixed another slide and did not do that. Sorry about that. Clustering is unsupervised learning, which I pointed out before as well. Regression is a supervised learning technique which tries to predict the exact numerical value. It's not predicting any category, it's predicting exact numerical value. The example which I've taken is from the medical side. In the early part of the kid's life, parents take them to doctor very often, right? Weekly and then monthly and up to 2 years, it's very often, right? And what the doctor does typically this, they take the several measurements of the kids, the height, weight, head circumference and all thing, and they plot it against historical data what they've got, and then they hand this chart to the parents in the end of the visit. And what this chart is saying is this kid who is just 2-year-old, at the age of 17, is going to roughly be around 155 pounds, exact numerical value, right? They're going to give you exact specifications. Now, it's not saying whether the kid is going to be underweight or overweight. It's saying exactly it's going to be 155 pounds. So whenever you're predicting numerical values, whether it is the weight of a person, the height of a person, the age of a person, how many $1 million the house is. In Bay Area, it's millions only, right? So how many millions the house is, that kind of prediction is called as regression. What I'm trying to do is fit an intuition in your head, which is primarily the first step a data scientist should have to think about this as a supervised learning or unsupervised, and then be able to think whether you're going to do one of these techniques out of the CCR, classification, clustering, regression. And these techniques which you need to apply and think like which one I'm going to apply, which my problem needs which kind of techniques. Is this making sense? Very simple examples, very basic examples, but hopefully this fits the fundamentals. Okay, I want to make sure the fundamentals are very clear. Everybody okay with that? Any questions?
So there is no regression in unsupervised learning?
There is no regression in unsupervised learning. You're just finding patterns. I mean, there could be a debate where somebody can say then this range and this range and this range, then it starts blurring, but it's still categories rather than say age from or weight from 10 to 20, 20, 30. If somebody thought, I don't know if you're thinking that direction, but it's not about exact specific value. Yeah. Now, what we did so far is some basic terminology. Now I want us together to apply that and see if we can solve and apply these principles together as a group. Sure, go ahead.
I was looking for a hybrid approach.
And elaborate.
Yeah, in that sense, you are predicting an election outcome, right? So there are leads coming in. At that point in time, you are already declaring a candidate as a winner, right? So in those, there is a supervised and both are hybrid.
Yeah, yeah. In real life, it will not be like you take one technique and you're done. You will end up most likely starting with some kind of unsupervised clustering, and then you go for supervised. I'll give you an example. Let's say you're working in a company and which is trying to tackle the problem of employee attrition, right? And the company is trying to build a model. It's a global company, and trying to filter one model for a global company is going to be very challenging. It may be better to apply a clustering model and say, oh, to divide that cluster, then in simplicity, there might be 3 clusters, APAC, Americas, in Europe, right? The cultures are very different, the style of working, the patterns, everything is different. You cannot think about iteration from what is happening, somebody's doing in US in certain ways, and somebody doing in APAC. It's going to be very different. So you may want to do this kind of clusters and then apply supervised learning in those kind of things to get the model, right? So in real life, it gets it. We're starting with the atomic level and then we'll build onto it. Now what I want to do is apply this into a real life problem, and actually I need all of your help to apply this. Right? We have learned some basic knowledge and information. Now let's see if we can solve together this problem. This is a classic problem. Every single company is interested in this. I've worked in at least 2.5 projects in this. One was prototype. That's why I have 2.5 kind of companies to give this kind of a solution where they want to find the unhappy customer to the happy customer, right? It's a very important, fundamental, rich bed of information which can lead to a lot of interesting things, right? Why are companies so fascinated about this? What's the value of finding this? Any few thoughts? Customer is the king, money, right? All of that, right? So cross sale, if you want to sell the customer more and more, going to this customer and saying, oh, the unhappy customer that buy this new product of ours, they say, forget the other product, I'm returning this as well. You can probably sell this to this customer. This customer is so valuable. My learning experience with the clients was there. Surprisingly, a lot of the companies start with this, or our mind is this, I want to tackle these unhappy customers. Surprisingly, somebody, a VP of a banking company told me like, no, I'm not even interested in this person anymore. I'm interested in this person. Because this person, the chance of converting is already 0. They're not going to get a business. To convert from the 0 to 1, when somebody has made their mind, they're mostly going to go. They're not going to stay. It's a business choice where you do not spend too much of energy in that. And she said, like, I'm interested in this. This is infinite opportunity for me. This customer, I can sell, cross-sell to 10 more products. He could be an ambassador, referring friends and families and everything. I want to focus here. That was a fundamental shift for my project and my initiatives, and we said from customer iteration to customer engagement. So just an insight, what we think and what business might make you think is differently, and it's very valuable information. So let's solve this problem together. I want to phrase the problem so that everybody is solving the same problem. Now, one way of phrasing this could be, let's find which customer is happy and which is unhappy. That's an easy problem to solve, relatively easy problem to solve. I don't want to do that. Let's raise the bar a little bit up. Here is what I want to solve. We have certain customers. Let's say a company has certain customers, some happy, some unhappy. A new customer signs in, walks in the door. I want to predict that new customer if he's going to be happy or unhappy, right? That person who is entering, he or she, whether they are going to be happy or unhappy. That's what we want to find. So we want to predict for a future customer, which is going to come in. Making sense? Everybody okay with that problem statement? So let's solve that problem statement. I have taught you very, very basic things, few things, not much, but we have done fundamentally a lot of ground which we have covered. So let's try to use a cheat sheet. I have a cheat sheet which will help us to really think through this mindset. And why I like the cheat sheet, it said Microsoft Azure, but it can be applied generically, and it should be fine. I'm going to share all the slides with you all, so you will have access to that, just so that you know. Why I like it? Because I have been doing this CCR thing for a while. When you take that CCR, what was the first C in the CCR? Classification. Thank you. All of this side, on this side which you have C, classification. Two-class, multi-class classification. Next C was in the CCR? Clustering, right? So this is clustering out here, and the R stood for regression. Thank you. So this is regression. It covers pretty much the whole landscape, except for anomaly detection, which is kind of a variation of classification itself in certain ways. So but it covers the whole landscape. So what I thought, we can take this concept of CCR and in a short period of time, apply that and bring people to really solve a real life problem statement, which I'm trying to do in a very few short period of time. Now, the way this works, it's almost like a board game. You start with a starting point, and then you go and asking each of these questions, and depending on that answers, it will flow in certain directions, right? And I need your help to really answer those questions. I'll talk of the questions, and then you can answer that. But let me remind the question again, because everything changes based on the question, what problem we are going to solve. To remind the problem we are trying to solve for a new customer, we are trying to predict the future customer, whether they are going to be happy or unhappy. Everybody okay with that? Yeah? Let's start. So that's the starting point. The first question, are we predicting future data points? Yes or no? Yes, I see a lot of nods. Yes, that's good. So that's our first starting point. So we move on to this question. Next question. What are we predicting? Are we predicting categories or are we predicting values? Categories? Okay, thank you, great. Let's keep moving. So this moves us to the categories group. How many categories are we predicting? 2. Happy, unhappy. That's it, right? That's what we're predicting. So we reached to a point of this 2-class classification. And kudos to you, good that you paid attention. And with a very, very small period of time, we just spent 24 minutes and we were able to at least bring this mindset. This is a very important first step. It's a very, very important first step. Over a period of time, you don't need this cheat sheet. You should be able to apply this very simply in your mind, and you should be able to do that and think whether you are going to apply classification, clustering, or regression. It's a simple tool to people to get started. You may not need that, but it's a good starting point in my mind. What we reached is up to here. What I did not show you or tell you so far is which algorithms to apply. Right? I think that's too much to do in a short session of an hour. But here's the good news is, if I picked any of these algorithms, I'm going to be mostly right. The question is, how much right? The question is, how much right? It's almost like a weather person who predicts tomorrow is going to be a rain, and it does not rain, and it's okay. The weather person does not get fired. Because it's just a prediction. It's a number. They don't see a guarantee. It says 20% chances of rain. So you've reached to that point. The journey of the data scientist from here on is to really keep modifying, tuning, building, trying different algorithms, trying different things to really keep building so that their accuracy, their concepts come as close as possible to the actual predicted value. So that's what the journey is. This is just the first step, but it's a very important fundamental step which we have to reach. And I hope people, I can see light bulbs going on people's eyes and faces right now. That's very useful. That's an important first step. The journey continues from there on. Let's add some more terminology to the concepts to our arsenal. Let's say we have a data set. Here I've taken an example of different lines of code, and it has gender, pair programming, two people doing programming together, and how many social media accounts they have. And based on that, we are going to predict, or for some data point, we have how many lines of code potentially they will write, or they have written. For this case, that it's already written. So we want to understand. So this is what is provided to you. It has a bunch of rows and columns, right, which we have. In the data science world, what we call these columns as features. So I want to make sure that we start talking that data science language now. And from here on, I'll use that language where it's called as features. You see a capital X. It's a matrix. It's a multiple field. So it's a matrix, and that matrix is represented by capital letters. What we are predicting, that's the output or the target. That's a vector, a single column which we are predicting, how many lines of code, and we are predicting that and saying as Y. Just for the checking point, like which of the thing is it? This is in CCR. Is it clustering, classification, or regression? Regression, right? Regression. It's exact a number. It's not saying that less code, more code. It's saying exactly how much. So good. Just checkpoint, right? So we got features, and we have something called as a target. So we have this kind of differentiation defined. Now what happens? Going back to the features, a data scientist will look at the data, and there is an important thing about the domain expertise what somebody has to have. And based on their experience, their domain expertise about that topic which they're trying to solve, they would define some of these features are useful and some are not. That exercise is called as feature selection. That exercise is called a feature selection. Let's say, not this example, let's take a common example which everybody understands. Let's say you're applying for a loan. One of the fields which you have is, say, your favorite color, right? Is that field, the answer to that question, is it important or not? It's useless. Whether your favorite color is red or green, it does not matter. You are going to get a loan or not does not depend on your favorite color. So that's not a field which somebody you want to put in your machine learning system. Whenever you have that, you will drop that field. So that is an exercise which you are removing certain fields, and that exercise is called feature selection. So you may have heard about this term, feature selection. That's what is happening. Which is the important step in the machine learning journey? More important step is something called as feature engineering. That really differentiates a senior data scientist with a junior data scientist. Your ability to do feature engineering. What is that? You're engineering a feature which did not exist. You have 3 fields here, and you're engineering a 4th field from the existing fields or some domain knowledge. For example, let's say you have a data about healthcare, and you have height and weight of a person. To predict the better weight of a person or how optimal weight, the right field, if you know, is BMI. BMI is the better indicator of how wellness of your height, weight, and all that indicator is. That could be a data in features engineered field. You're taking the existing fields and creating a BMI field. So whenever that you're doing that, you're improving your data set, and your chances of getting predictions better and better is going to be much higher. So along with feature, you have to understand these 2 concepts, feature selection and feature engineering. Everybody okay with that? So these 3 steps which are building that we need for the overall journey. So we have features, we do feature selection, which is feature engineering. We try to predict the target values. And of course, we have several rows with us. In the data science world, we do not call them as rows, right? We want to have its own terminology and language. It's called as samples or sometimes as observations. So you have 100 observations or 1,000 observations or millions of samples of data which we have. So those are basic terminology, just to make sure everybody is together. So as we start taking and start using it, everybody's along with that. So we have this data point. Now machines will be fed this data, selected features which will be fed, but machines do not like textual data. Machines do not like textual data. So if we have a gender, male and female, the machines would prefer to have it 0 and 1s. Binary kind of values, any kind of numerical values. Machines work much more effectively with numerical values, not with textual values. What we are doing here is an exercise of cleaning our data or preparing our data, which is a lot of time which is spent doing this exercise. This step is such a crucial step. Your data is never clean, except in training environments. It's always messy, and it has lots of issues. Whoever working in the data science world, they really understand that. How much percentage does the time people spend, usually the data scientist spends or data professional spends on cleaning data, preparing data versus actual machine learning? 80-20, 90-10. Whoever is saying higher is worked more in the industry, right? If somebody is saying less than 70, I would say they have not worked in the industry. They've done some training things, or less than that. Most of the time is spent in cleaning and preparing your data in such a format and this kind of thing. So once you have done that, once you have done all this preparation, this was just a quick example. There's tons of things which you can do in cleaning, but this is a quick example. Here is what the machine see. Oh, I have this bunch of X columns, and then I'm predicting a Y column. That's what I'm predicting. Once I've predicted that value, that's a complex formula, which if I told you to eyeball this and tell me a formula or a model, you would have not been able to so successfully get that. You were able to say that cube thing in the beginning very quickly, but this is not something I didn't even challenge you, because there's no point trying to that. The machine is able to do this very quickly, and is able to identify exact pattern or what's their best attempt to do that. Now, which of the fields or features is the most important by the machines? Which feature is the most important based on this? X1, which is the number of pair programmings. If you notice, the third one, X3, which is social media accounts, which you have, it's negative. Because the more social media accounts you have, the more time you spend into that. It's kind of waste from this perspective, and that's why it's not giving you the better numbers, right? What this also is saying, the data is saying, that ladies write 2 more lines of code generally compared to the men's. That's what data is saying. I'm not saying anything, right? So I'm not starting any conflict here. But that's what the data is saying in this particular scenario. And I agree, they do. A lot of more work than men's do. So this is what typically will happen. So we talked about few terminologies. We talked about how to really look at your data features, do feature selection, feature engineering, predict a value, and the machine has got this value, and it can be put as a model for future predictions. A new person comes in, and you can predict that. Of course, there will be a talk of algorithms. A lot of algorithms will be talked about. As I pointed out, I'm not going to go in much detail in algorithms, but of course, you cannot have a conversation without algorithms. There are a lot of algorithms. Some of the popular ones in the list, I want to throw it out: supervised learning, unsupervised. And I did not talk about reinforcement learning, which is almost like a trial and error. You do mistake, you learn from that, and just keep improvising. In fact, machines are playing a game. Whenever you're doing all these things, they're just, in their mind, they're just doing one thing. They are trying to reduce the error. They're playing a game so that they can reduce the error and get as better and better. Whatever you are trying to do is your business problem, your personal project which you are trying to do, but machines are just trying to do this one single thing, which is algorithms. I'm not going to go to each of them, but you must have sure heard of several of these names and kind of a thing. An hour, I think it's not especially for a starting kind of a conversation, that algorithms are not necessary. I can't go into detail of that. But they're going to be a key part of that. Now let's try to sum it up all together and put a very simple data science process, what a data scientist will do. And I want you to remember this so well that if somebody wakes you at 2 a.m. in the morning and asks you a data science process, it has 7 steps, but you should remember it. And I'm promising that you will be able to do it very soon, right? Why I'm so confident about it? Because as you said, some of you said, 90% of the time is spent in cleaning the data. I have created an analogy, another analogy of diapers. It's a 7-step process, and it's a perfect analogy because the extreme kind of cleaning, parents know it very well, is this. It has all the visual, the smell, everything, the waking up in the 2 a.m. in the morning, everything. So diapers is a perfect analogy for that. What I've done is created these 7 steps. Each of these initials letters stand for a step in the overall journey. And I think you'll be able to remember that much easily compared to if I gave you arbitrarily 7 steps. What are these 7 steps? Let's go together with it. And I hate this. This thing is sometimes like these projectors are making it difficult, which is also a good opportunity to talk through it, right? Or to get together. I will talk about each of the steps. First is define your problem statement. That's the number 1 thing. Like majority of the startups or companies fail, projects fail, is because of that. Your project statement is not correct. Your problem statement is not correct. People are making products which nobody wants. Sitting in a vacuum thinking let's the best idea rather than solving a real problem statement. So defining your problem, I cannot overemphasize the amount of effort and energy which will be needed to say you should spend more and more time in defining your problem, clarifying your problem. So that's your first step. What are you trying to achieve? So D stands for defining your problem statement. I stands for identifying or ingesting your data. I used to use ingesting of data. Somebody said identifying. I like it. So ingesting or identifying your data set. What data do I need to solve that particular problem? Oh, I need some data coming from the CSV, or I may want to have some data from a database, or I may have to tackle a big data kind of environment. All of that is possible, right? And it changes the whole game. Now, companies have an engineering team, data engineering teams, who are building data lakes, data warehousing projects, 10s and 20s of people just doing this function. It's a lot of work. Especially it gets more crucial nowadays, especially with the GDPR, privacy, and so many different things which you have to keep in mind, and this step has become more and more crucial. So that's what ingesting of data plays a very important role. A stands for analyzing your data, understanding your data, whether I have clean data, whether I have all the data sets which I need, do I need to go back and get more data, or do I need to clean my data and remove some of the data sets, all of those possibilities. P is preparing your data. Now I understood my data is not enough, I'm going to get and collect more data. I'm going to maybe clean some data, like the ones we did from female male to zeros and ones. Most of the time people mandatory fields are not filled in, you're going to fill in some data. All kind of different formats of cleaning which you'll do. So the fourth step, which is not showing up here, is prepare your data. Out of the 7 steps, 4 are done. We did not talk about machine learning at all, right? And that proves also the point, the majority of the time, it's data. Less about machine learning and algorithms, but it's more about data. So most of the time is spent in data, around 80%, 90%, whoever said that, perfectly right, and that's the amount of data which goes in analyzing and preparing the data. Then comes E, which is evaluating the models. Data scientist is not a magician who's going to just take out of the hat and say, this is the algorithm which you're going to use. It's a very scientific process. It's called data science for a reason. It's a very scientific process. You try different algorithms, 5, 6, 10 sometimes. You different algorithms which you're going to try, and then you're trying to see what's coming out better in my particular scenario. It's a very iterative, painful, detailed, going into crunches and trying to solve that problem. It's going to take that kind of thing. So multiple algorithms. After that, you will finalize these 2 algorithms are doing well for me. Just 2 simple algorithms are doing well for me, or this particular algorithm is good for me. I'm going to go and tune that particular algorithm, which is called as the refine the model step, which you are refining and trying to identify this model is going to be the final model which I'm going to take it forward, and the S stands for ship it. Let me do one more click. It does not, I hate that. It is not showing up at all. This is, I'll repeat, or let's together repeat. Let's see if we all can say it together. What is the D? Define the problem statement. Great, thank you. I, ingest the data. A, analyze the data. A lot of work is gone. The more time you spend in analyzing, the better you're going to be up front. It's like sharpening your saw. That's the time which you have to spend there rather than thinking about algorithms. Spend the time there. P, prepare your data. So all the cleaning, all the fixing of data will happen there. E, evaluate the models. Several different models, you're going to evaluate the models. R, refine the particular model, 1 or 2, last finalist kind of a thing which you have selected. Thank you. And finally, S, ship it. The productionize it, ship it, and this needs a lot of these regular software engineering steps which you have to really make. Monitoring is there, logging is there, error handling is there, all of that has been taken, automation is there, all of that has to be accounted there. Yes. Question?
You are saying cleaning it all, unless you know the outcome, right? What are you cleaning? You are cleaning white or you are cleaning black, right? So that means you are doing a reverse engineering from the game.
For benefit of everybody, if I want to generalize what cleaning is, let me phrase it that way. There is a lot. Cleaning is a huge topic. There are a lot of startups we mentor and do kind of a thing, and they talk about let's create a product which is going to clean data. I can tell you there is never going to be a company or a product which is going to have a click button and say, clean my data. Because what is clean? It's very, very subjective. What we mean from your cleaning, it can, of course, in the context of thing, it changes. Complete somebody's treasure is somebody's garbage, right? So the other way around, to look at it that way. So what we are looking is those female, male, one example which I gave, some fields which are mandatory, which we need our data kind of thing, it's not there. Some things which are put in a different way. Somebody is writing Mr. and somebody like MR, dot, all kind of different conformations and kind of things which are being the things. Tons and tons of things, all of those things possible. Coverage kind of things which you are trying to make sure the data is kind of thing. There is a whole slide deck. Yesterday one of my colleagues did it and I can point it to that. Both. It's actually coming from both the sides. It's coming from both the sides. You're looking some of the pure data issues and trying to fix that. And then the other side, you're looking also from the problem's context. Am I getting the right field? If I have a problem which needs the age field, so I'm just going to jump into an example. Titanic is an example which several people use in the data sets. How many of you use the Titanic data set to try something anytime? Okay, but you have watched the movie Titanic? Now everybody's raised, their hands go up. right? If you're predicting a Titanic kind of a model where you're trying to say whether the person is surviving or not surviving, that's what one of the classic problems in Titanic you're trying to solve. One of the most important field is age, the age of the person, because you've seen the movie, so who survives in the Titanic most time? The heroine? Okay, she does. I get that. The ladies and the kids, right? The ladies and the kids. So it's gender and it's the age. Those are the two most important things based on the context of my problem. Actually, when you take the Titanic data set, the age field is not completely filled in. So that's a problem in my context of my problem, coming from the right, as you pointed out. In that scenario, I have to fill in the age somehow or the other. And there are classic ways people data engineer and do different things. And the more better you put that age correctly, and there are ways you can think about certain things. It's a fun problem to talk about for half an hour at least. But that's different ways to fill in that data and then. And there are some things which I talked mandatory fields and other things from the left side. So it's both the sides. Good question though. Good question. So that's a simple example. 2 a.m. in the morning. Anybody can answer. What's the overall data science process? I hope you can do that now, right? At least you don't have to do that. But if your baby is crying for diaper change, you have to get up. For this one, you don't have to. Okay, so that was the overall data science process. Now let's quickly talk about some of the offerings. The industry understands, the larger companies understand, it's a disrupting force and they need to make the best of this opportunity. So every big company is trying to get their share into this whole revolution. Amazon in 2015 came up one offering called machine learning, Amazon machine learning. So they have one of the services in their AWS stack. Within weeks, literally, Google came out and said they are open sourcing their machine learning internal tool, which is TensorFlow. It has been viral after that. Everybody, there's a huge community following, which has followed Google's open, it's been open sourced. Microsoft came late to this whole game of cloud, and of course, machine learning as well. But I think they did a decent turnaround. Satya Nadella has done a decent turnaround and turned the company around, and they have an offering on the Azure machine learning offering on their offerings on Azure. I'm not biased on Microsoft, but I would tell you like it's truly a drag and drop kind of a tool. So somebody who does not have coding background may want to try this first. And it's free. You can just get in without subscription, just sign up and start using it, drag and drop this algorithm, that algorithm, it is there. Of course, there's a point where you'll stop limit and you'll have to start coding. But it's a great starting point if you are not a programmer and coder and you wanted to try that out. The fourth option, which I'm going to put out, is Spark machine learning. So how many of you have heard about Spark? Quite a few. Whoever worked in the big data side of it, they have heard it. It's one of the components in the big data world. And it's a processing framework, a very powerful and strong framework, which does processing of all kinds. And machine learning happens to be one of that format, right? And this has a processing. Most of the time when you're solving this data, Amazon also has it. Most of these things have Spark embedded underneath the hood. And whenever your data is humongous, and you're dealing with large data, you will end up coming here eventually in some form or shape. Most of the companies will come up here. So these are packaged offerings. What these companies have done, I call them as distributors. Rightfully so, because they're just distributing open source software on the cloud. They're not the inventors of this. They have mostly packaged in, with some exceptions, I'm generalizing the statement, but they're just bringing those applications, the services packaged in a cloud format, right? That's what they have done. Spark is open source. TensorFlow is open source. These two are proprietary. Of course, Microsoft and Amazon that way. Then you have the option of using simple programming to do these tools. And Python is the winner, and it's killing all of that languages at this point of time. It's an era of Python. At least for next couple of years, I think it's all about Python, Python, Python. The other option typically is R. R is a statistical language for decades. It has good amount of data science capabilities, modeling capability as well, but right now, by far, Python is leading. And it's a very easy to learn language as well. So if you're wanting to get a starting point, that's your entry, and it has powerful tools and libraries to be able to perform machine learning in there. So that was up to machine learning. Now I want to switch the gears. We'll take quickly a question or so if anybody has. I'm a little behind, I can feel that. So I'm talking faster, you can see that. But that's about machine learning. Any quick questions, anybody? Everybody okay with that? Because these things which we'll need forward as we move forward. Okay, so then let's compare our overall theme, go back to machine learning, and that's the way it started. Machine learning became a lot of excitement till several years, and now the excitement is shifting towards deep learning and AI. So let's compare that. You will hear and see this kind of a visual very often in different kind of visual, which will say AI is the big umbrella, and then you have machine learning, and then you have deep learning. My colleague Anthony yesterday showed us well this slide, but this is a very correct statement, but it's not fulfilling. It doesn't give you the picture. What really means this big umbrella, and under that you have this, and under this thing. It's a subset, we understand that. I spent a lot of time to really decipher it and make it as simple as possible, and few things which I'll attempt to really make that easy as well. We already talked about machine learning. We have some input data. We talked about feature selection, features engineering. That's all feature extraction in general called. You will try in a different algorithm, and you will predict the output, right? Car or not a car, something depending on your use case. What deep learning is doing, it's making a black box to this whole exercise. And it's taking some of the work, and it's kind of automated machine learning. I'm generalizing that statement quite a lot. It's automation of machine learning, where you do not have to do select features. You do not have to define what tactics you're going to use, and the machine is themselves going to pick up and do deep learning, right? And do that for you and give you the output. And many times it will be better output than machine learning. Most of the times, not always. Now the question somebody will say, then why I would want to use machine learning at all? Why don't I just move to deep learning? Yes, a lot of action is happening to things, but to me, it's not an or, it's an and. And I'll explain why that's the case. What I did is, like, I spent a lot of time trying to summarize everything about machine learning, AI, and deep learning into one single slide. And this is the slide which I came up pulling out information from the net and different sources and different places into one combined sheet so that we can compare and contrast this. I'll go to AI a little bit later. We talked about machine learning, so first let's tackle that. Machine learning around 1980, which just started more of that revolution. What it is doing, it's doing one specific thing. Dog or a cat. Person, this is a fraud transaction or not a fraud transaction. Getting a bank loan or not. It doesn't have to be two things, but solving one particular problem. And okay. One particular problem. The benefit or the good thing about machine learning is this. It does not want humongous amount of data. Even if you have a CSV with few hundred rows, you can do machine learning on it. I cannot say that about deep learning. Deep learning needs humongous amount of data to really be able to give any sensible prediction. Because it's trying to figure out all those things itself, so you need data. When it needs data and it's handling such amount of data, it also needs huge amount of compute capability. And that's why GPUs and cloud computes and all that thing will be needed. Mostly a standard laptop will be hard to do much of deep learning exercises, right? So that's the difference. So also that you cannot think about that is the only hammer which you're going to use and use always deep learning for every single thing. It's not. It's based on your case-to-case scenario, based on your data size, based on your need, you may have to make a choice. Some of the things which deep learning, which started back in 2006, the term was coined, and interesting things which it does, it deals much better with the unstructured data. Images, audios, videos, these kind of data. And you may have seen on the net a lot of black and white images converted to color, right? And that's what deep learning is able to do it. How it does it? Let's say somebody has an old image which is black and white, it has an umbrella. What it will do is first it will do an object detection. It will say umbrella. Typically an umbrella is usually black. So it will paint that thing as a black color image. In fact, that actual reality when that happened 50 years back or 70 years back, that umbrella may have not been black. But it will just do this because of the nature of how deep learning is going to do it. It's not going to be accurate, but it's going to fulfill that job. So that's how it does it. A lot of interesting things which it can do. It does need a lot of different data sets. We talked about some of the algorithms or touched or just highlighted. Similarly, what we have is neural networks, convolutional neural network. You have RNN, ANN. I'm not going to get into those things, but briefly we'll touch that a little bit, but not much. And we use Keras and TensorFlow and these kind of applications. So that's kind of the high-level difference. Now what AI is, in my mind, it has been there for a while, as we talked about in the very first slide. And what AI is doing, it's using machine learning, it's using deep learning, and creating applications, actual use case or pattern, which you can use. For example, driverless cars. And that has to be almost like a human being who's trying to drive the car. A machine is trying to mimic that some behavior. So that's where AI comes into picture. AI has lots of different benefits and advantages compared to human beings, and that's why they're able to do driverless cars, Alexas, are possibilities. So that's how I look at it. Now let's spend a little more time on AI. Generally, there are two types of AI. One is a narrow AI, which we have tamed it. We have addressed it very well. all these specific tasks or small things, which can be machine learning, you can think about it that way, and spam detection, historical data, predictions, all of that has been done. Now what we are really striving for or moving towards general AI. And general AI is really powerful, sophisticated, has social implications, and a lot of challenging. That's why it's taking much more time. And it has job impacts, a lot of scenarios being talked about of doomsday and all of that kind of thing. So that's what we are heading towards. If you look at it from a different angle, AI, as I said, is a combination of machine learning and several of these capabilities with deep learning and other things try to do. You have NLP, you have speech, all of these kind of things defined. If we were to summarize in a simple way, AI is, as it's trying to mimic a human intelligence. And human beings have intelligence based on their senses. The senses are playing a very important role. And I think machines are trying to get those senses over a period of time. We have eyes and vision, and so do machines. They have computer visions. In fact, they have become much more powerful in this category than us. If you find your friend 20 years later somewhere and you meet him, you may not be able to recognize. A machine is going to recognize it very, very correctly. And you can take a kid's image, and 50 years later you can find that image, and it is able to find. The applications, which Facebook and others have in facial recognition, they are 97% accurate and able to get and remove all the bias which human beings have. Facial fears, different kind of scenarios, angle, the light, we get biased. Machines do not. They have become to such a point, they are able to do this much better than us. Of course, they have their own challenges, but they're getting much better as they can. It's used for object detection, there's a dog, there is a car, or they're doing facial recognitions and used in many, many applications. Speech. We are able to talk, communicate to each other, right? And machines have become like that. You are using audio more and more to say the directions, get me home, and interact with Alexas of the world, and you're getting responses. That word which you're speaking is converted in from voice to text. Some commands are taken, output is resulted, that's converted back from text to audio, and Alexa is responding back to you. A lot of action happening in the spur of a moment. You do not realize how much amount of churning of data is happening to make this happen. But machines are able to do that very well. One thing which machines thrive and more successful in that is memory. Their memory is way, way, way better than us. As we start aging, our memory start fading. And even in fact, I would say forget age. We should not rely on our memory strength. Our memory strength is the weakest. Machines are much, much better than that, always have been, right? And that's why we use that capability. And they have a huge, huge knowledge base to go back the world and different databases and applications which they have. And what they have done with all this capability and ability to search for an instant answer. For example, Google is moving from the scenario where you ask a question, it gives you hundreds and millions of answers. Instead of they are creating something as a card, which gives you one answer, not thousands of answers. If it is one definite answer, then of course they are giving you scenarios and everything. Many of you may have noticed that in Gmail, you type a few sentences and it starts auto-completing. How many of you have seen that? Such a cool feature. It's automatically writing. I'm now in Outlook also, and I'm typing it. Why is it not completing? It does not, it's Outlook, right? But Gmail is able to do it, and it's such a sophisticated kind of thing. Even if you just search, if you write 3 letters, Google knows what you're trying to type. And probably the first 5 things you're thinking, whatever you're thinking is in the top 5. They know much more than that. What maybe your spouse knows about you, Google knows more about you than your spouse. Scary, but that's truth. So what I want to summarize is, over a period of time, that's what is happening. Machines have been getting slowly and steadily building the senses one by one and have their own strengths and combine together to give us the results which we want in sophisticated applications. Again, similarly, as the applications industry has, Amazon has created their own offerings on there. They have something called a SageMaker. I wanted to give you that glimpse of what options you have. Google has TensorFlow, of course, which can do deep learning, machine learning, AI as well. They have something called as AI Hub. Microsoft has Cortana, and they have Azure Bot and several other kind of thing in their stack. IBM Watson is pretty popular. They also have machine learning offering, but I had to restrict certain, so I've not put that on that side, but they are present as well. In interest of time, I'm going to rush quickly with these industry use cases. I have very few minutes left. So what's happening in the AI world? A lot of action is happening. What is predicted by 2020, and in fact, a lot of sites are moving their interactions, customer services into chat and intelligence, which is written in voice, and 80% of that is going to move there. It's already happening. E-commerce is using that very, very effectively, very powerfully to the scenarios. If you watch this Noah video, Amazon has this warehouse with tons of robots running around, doing all these things and taking over a lot of the work and giving you same-day delivery or the next-day delivery. It's all possible because of this kind of sophistication and automation. In the healthcare sector, there is this virtual doctor, Molly, which is especially for senior citizens or some things. There is a device which keeps you on a daily basis, takes you steps and monitors, and you interact with it and takes your vitals and does it. You're okay, you need to do this, you don't do that. So it's an impact on the healthcare side as well. Healthcare has a lot of impact. In fact, more and more changes are happening. If you search for, this is checking your retina images and then looking at the blood pressure and diabetes and all those things are also being regulated as well. Uber and Lyft, using it for machine learning for supply and demand, route optimization, and several of these things which they have done and build billion-dollar empires just because of the data services which they are able to provide. In the banking sector as well, there is front office, back office, processing loans, all of that has, a lot of that has been transferred to AI and machine learning. Here is a glimpse by sectors. There is not a single sector which is not impacted. Pretty much every single sector has been impacted on machine learning in some form or shape, AI in some form or shape, on some startup, and things are happening right now in so many different sectors. A lot of positives, but also there is a downside to this as well. AI and the ethics. There is a lot of talk these days about this, and rightfully so. There is a major impact on our lives, the human civilization is going to turn around in future, right from the extreme of our privacy impacts to how this is ethical. Are we creating another kind of species? Are we creating a threat to our own thing? How is the transition from human beings? Every transition technology which happens, the answer is like people will transition, they will learn it. I believe, and a lot of people believe, this one is a big jump. Converting everybody to a robotic or a computer engineer is not that easy, right? Taking all your truck drivers, all these different roles and kind of thing. In fact, the funny thing is, a lot of things I talked about in the AI world is about the low-end jobs, the flipping the burgers and all the things. Actually, now it is becoming more popular that actually the high-end jobs are at risk as well. The examples of scenarios where doctors, I'm not saying the job at risk, but I think those can be taken over as well. JP Morgan Chase has devised a system, AI system, which can look into contracts, and they can do in an hour, which is hundreds and hundreds, thousands of things are being converted into by thing. Instead of a lawyer just doing few seconds, it is being done by so many hours, by a single hour by machine learning. Which brings us to the thought of a lot of people are saying the Skynet and the Terminator kind of vision or the fear. I'm not going to take that, and the last slide which I want to quickly point out is our optimistic view at the world where AI is able to do a lot of fun things and simple things, coloring the images, black and white, that's just fun things, but at the same time doing sophisticated things for disabled people and everything. With my leg injury, I was wishing that I had that something I had so that I can come driving myself. Over here, there is scenarios where machines are able to go into nuclear reactors or fire hazardous situation, and then human beings don't have to do this. And also in the healthcare, where a single image scan which you can take and can detect whether a person has a cancer or does not have cancer, and then early detection is going to be key for every prevention and the cure of the disease. So what we did in a very short hour, we started with very, very basics. I started from machine learning basics, compared supervised to unsupervised. I hopefully gave you a few very simple terms so that you remember, and remember for a long period of time. We talked about CCR, we talked about the diapers model, and compared how machine learning started, build onto it, and over a period of time compared to different offerings. And I want to leave you with a hope and a bright future. I know there are challenges and downsides to the AI as well. Everything has side effects, but I would long to give with a positive note, which I'll end to it. Thank you very much for joining in. Thank you for the session. And thank you for being in there. I'll take questions. I'll let the other gentleman get a setup done, but thank you very much. I'm going to hang in here.